Today, we're going to talk about exponents, specifically rules about dealing with exponents. We have a lot of different rules when it comes to exponents. So today, I'm going to give you 2 rules, and then the next lesson, we're going to do a couple more, and then a couple more, and then at the end, we're going to be able to put them all together. Separately, these rules are going to be pretty easy. The problem comes when you start putting them all together and keeping them separated and keeping them on track so you figure out what's going on. Before we start this, let's go over a very basic concept of exponents. If I were to give you 4x to the third, what does the 3 do? Is the 3 telling me x to multiply x times x times x? As we know, exponents tell the base, what we call the base, to multiply by itself that many times. Is the 3 with the x? Is it with the 4? Is it with both of them? The x is what we call the base. The x is what we call the base. It is very, very important in all of your problems starting today to be able to figure out what the base is. You always have to be able to figure out the base. The base is the part that's connected with the exponent. So in this case, the 3 and the x is your base. The 3 is talking to the x. It's x to the third. It's not 4 to the third. It's not 4x to the third. It's x to the third. What this is actually saying is if I were to write this out, it is 4, and 3 x's. X to the third means x times itself 3 times. X times x times x. X to the third, x times x times x. Now, if it was 4x to the third, then the base would be both of these. So it would be 4x times 4x times 4x. But when it's just like this, the 3 only goes with the x, not with the 4. It's very, very important through this whole chapter that we're starting today to understand what the base is. What the base is. The base is the part that goes with the exponent. So in this case, the 3 goes with the x, not with the 4. Okay? You have to always be able to identify the base. And you'll see why when we start doing some examples. First thing we're going to talk about is zero exponents. What happens when your exponent is the number 0? The base equals 1. It basically will cancel itself out. The base becomes a 1. So for example, what is 8 to the 0? What is 10 to the 0? What is 100 to the 0? What is 4 to the 0 power? If you try these on your calculator right now, most people will think you're going to get 0. But in fact, the answer is 1. Anything raised to the 0 power is always equal to 1. 5 to the 0 power is 1. 10 to the 0 power is 1. 3 to the 0 power is 1. If you try on your calculator, always equal 1. So x to the 0 equals 1. Anything raised to the 0 equals 1. Now, I phrased this very specifically. I said the base equals 1. Not the whole thing. The base equals 1. Now, that doesn't make sense to you now, but it will in a second. The other part that I have, which probably doesn't make sense to you yet, but it will, is cancel it out. When it's a 0 exponent, you're going to cancel it out. We'll talk more about that in a second. So when the exponent is 0, the base becomes a 1. Next thing I'm going to talk about is what happens when your exponent is a negative number. So what happens when it's 4 raised to the negative second power, or 3 raised to the negative third power? That does not make your answer negative. That is a common misconception. It does not make the answer negative. Here's what you're going to do. Now, I'm going to give you it in words. It's not going to make sense to you, but I want you to actually be able to read it before we get started. When your exponent is negative, you're going to take the exponent and its base. You're going to bring it to the other side of the fraction. Okay, I didn't put that in there, but you're going to bring it to the other side of the fraction. So if it's in the numerator of the fraction, you're going to bring it to the denominator. If it's in the denominator, you're going to bring it up to the numerator. And you're going to switch it from negative to positive. The exponent becomes positive. The exponent becomes positive. So for example, if I give you 4x to the negative third, my exponent is negative. We're going to make this into a fraction, which as we know is just over 1. Okay? I'm going to take the exponent and its base. This is why it's important to know what the base is. What's the base of the negative 3? It's the x. It's not the 4. This is why I like to circle, and you'll see me do this a lot, the exponent and the base. It's very important to know what the base is. and you're going to bring it down. Okay? Exponent and its base to the other side. So it was on the top, it was on the numerator, we bring it to the denominator. So now what is remaining on the numerator? What's on top? 4. What's on the denominator? Well, there's a 1 there, but there's always a 1. But I bring the x to the negative third down, and it makes it positive 3. This is my answer. 4 over x to the third. I brought the exponent and its base, bring it to the bottom, bring it to the denominator. When I do that, it makes it from a negative, and it becomes a positive. The 4 stays on top because 4 is not the base. The base is the x, and that's why it's important. That's also why it's important to circle, because it will see it. Because I see a lot of people who do this, and then they bring it all down. So it becomes 1 over 4x to the third, and that is not right. The 4 needs to stay on the numerator because it's not considered the base. So let's do some more examples. X to the negative fifth. We have a negative exponent. The directions want us to simplify. In order for it to be simplified, we can have no negative exponents. In order for it to be in simplest form, we may have no negative exponents in our final answer. So if I make it a fraction, I'm going to take it in the base, I'm going to bring it down. What is remaining on the numerator? What's remaining on top? Nothing, which means there's a 1 there. And on the bottom, I have x to the fifth. Eight to the negative second. What is your base? Your base is your 8. We're going to take it and the exponent, and we're going to bring it down. Your base doesn't have to be a variable. Your base could be a number. Now, what is remaining on top? Nothing, so there's a 1. 8 to the second. The negative 2 becomes a positive. When you move it from one side of the fraction to the other, it becomes a positive number. And 8 to the second is 64. So that is your answer. So this is what happens when your exponent is negative. You're going to take it and the base, and you're going to bring it to the other side of the fraction. So let's do some examples. 5,845,123 raised to the 0. Remember I said, it doesn't matter. Anything raised to the 0, the answer equals 1. That is your answer. It doesn't matter what the number is. If it's raised to the 0, it equals 1. Now saying that, this next example is x, y to the 0. Now you see the 0. Most people will say, well, the answer is 1. That is not correct. If you go back to the rule, I said the base equals 1. Not the whole thing, just the base. So if we look at this example, what is the base of the 0? It's the y. So this part becomes a 1. In a sense, it's x times 1, because this part becomes a 1, which is just x. The other thing I showed you earlier, and I said it will make more sense later, is you cancel it out. Anytime you have something raised to the 0, you just cancel it out along with its base. So the 0 and the base both get canceled out. So in a sense, in this problem, this part gets canceled out because it's the base, and what is remaining? X. And x is your answer. So if you have something raised to the 0, the base gets canceled out along with the exponent. 10 y to the 0, t to the negative fifth, all over 6x to the third. Okay? This is what most of our homework is going to look like. We want to simplify this. In order for it to be in simplest form, we must reduce and simplify all the way our coefficients, which are the numbers in front. So I have 10 and 6. We're going to simplify this fraction just like we're back in 6th grade and you learned how to reduce fractions. So what goes into both 10 and 6? 2. It reduces down to 5/3. So the coefficients have to simplify and reduce just like a traditional fraction. Now, I see a y to the 0. I don't want that. It gets crossed out. I have x to the third. Do I have any other x to the thirds? No. Is it negative? No. If it's negative, I have to move it. I cannot have any negative exponents in my answer. We talked about that earlier. No negative exponents in your answer. So x to the third can stay there. Now I have a t to the negative fifth. I need to circle it and the base and bring it down to the bottom. When I do that, it becomes t to the fifth. That is my final answer. 5 over 3x to the third, t to the fifth. The order does not matter. You could have put t to the fifth first and x to the third behind it. The order doesn't matter because I'm multiplying them. So once again, break it up and look at each part. 10 over 6 reduces to 5/3. The x to the third stays there because it's positive. The y to the 0 crosses out. And the t to the negative fifth goes down and makes it t to the positive fifth. Let's look at another example. 3y to the negative fourth, t to the 0, all over 4 to the negative second, x to the third. Just like the last one, if you break it up and look at one part at a time and not the whole thing, it shouldn't be too bad. So I see a negative 2 and a 4. I'm going to bring that up. I'm also going to cancel this out because it's 0. And I'm going to take y to the negative fourth and bring it down. If it's negative, you have to move it either from the top to the bottom or from the denominator up to the numerator. So now in the numerator, I have 4 to the second and I have a 3. 4 to the negative second became 4 to the positive second. There's already a 3 up there. On the denominator, I'm going to have x to the third and y to the fourth. X to the third is on the bottom, y to the fourth is now on the bottom. So now in the numerator, all I have to do is combine these. I have to do 4 to the second and make it 16. So it's going to be 16 with the 3, x to the third, y to the fourth. And now I have to combine those two. I have to combine these two together. After I do the exponent, you have to do the exponent first. I am then going to multiply them. 16 times 3 is 48. So 48 over x cubed, y to the fourth. It is in simplest form if your coefficients, so just the number, the big numbers, not the exponents, not the variables, the coefficients are in simplest form, and if I have no more negative exponents, which I do not have any negative exponents. Last example. 12 raised to the 0, y to the 7th, over x to the negative 11th. All right? So we need to reduce this. I see a 12 to the 0. Well, that gets crossed out. I have a fraction. I have x to the negative 11th, and we're going to bring it down. So what is on the numerator? Y to the 7th. On the denominator, I have x to the 11th. This is my answer. Because my coefficients are simplified, I don't have any coefficients, and all my exponents are positive. Remember, you can have no negative exponents. If you have a negative exponent, take it and the base, bring it to the other side. If your exponent is 0, we're going to cross it out. In the next lesson, we're going to get 3 more rules of exponents that deal with multiplication, and then we're going to end up combining them with these two that we learned today.